Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on how to deliver software better and faster.
If you're looking to build, test, and ship, tune in, let's confidently commit.
You're listening to a bonus series all about AI. I'm your host, Rob Zuber, CTO of CircleCI, the industry leader for all things CI and CD. And today I'm joined by CircleCI's very own Michael Webster, principal engineer. Hey, Webster. Oh, we're going to call you Webster on this show because that's what we do. And I don't know how to do anything else. All right.
Be consistent.
Hey, Webster. Thanks for joining me.
Hey, Rob. Thanks for having me on.
Yeah, you bet. I'm super excited about this. I unsurprisingly know lots of what you've been working on, but I think that, as I look around, there's so much desire for information and how do we make progress? How do we figure out product, et cetera? And so excited to dive into it and share it. So just to kick things off, can you tell us a little bit about what you're working on at CircleCI on the AI front, sort of what areas you've been exploring and what kinds of things you've been trying to achieve?
Yeah, absolutely. I would say I would maybe put it into two broad buckets, right? So AI is a very exciting technology right now for people building software, both sort of building software itself, having AI write your code, find bugs, that sort of use case. But then there's also sort of more and more people building software with AI, and then sort of how does that change? How does it change, and how is it the same in a lot of ways to how we typically think about software delivery? So on that first bucket, sort of applying AI techniques to building software itself. I've worked recently on, I think you chatted with some folks about the error summarizer. So this is kind of hey, we've got these really long stack traces. Can we kind of quickly give you recommendations of what the problem is, so you as a developer are not having to kind of eyeball through a very deep Java stack trace. Also looking at the idea of using AI to sort of just fix the bugs for you, right? If we have a thing that can write code, can understand errors and explain and come up with suggestions. If we give it some extra context of what you, the developer, are actually doing with your diff, can we fix it for you automatically? That's still a little more experimental, but that's kind of on the AI for software. And then most recently, what I've been focusing on is if you're building an AI empowered product, we've ran into these problems, right? We've built this tool to do an error summarizer. How do we make sure that it's good? So thinking a lot around, okay, you've built this AI product, you can get up and going really quickly. How do you make sure it stays working? How do you make sure you can run it in a cost-effective way? And also understand when it breaks, because at the end of the day, we are still kind of writing software.
Got it. Well, let's follow that second trail for a second. You mentioned a couple things in there. How do I know it's good? How do I scale it up? What's sort of uniquely challenging, and maybe go into a little bit more detail around those or other things about building and testing AI-enabled applications compared to sort of your background, our background as an organization, building and testing, we'll call it classic software. I don't really have a term for it yet, but non-AI enabled products.
Yeah, totally. I mean, I think by far the biggest issue that you have is that the output of these large language models in particular are probabilistic and non-deterministic, right? So when you're writing software in a classic software, you define your business logic, right? You can sort of trust that the database, if you issue a query on data that you put into the database, it's going to come back in the same form as you wrote it. You really don't have a lot of those guarantees with language models, right? And that makes sense. Language is subjective. There's lots of right ways to answer the same question with different wording. There's different styles that you might want to impose. So that probabilistic aspect of it. And then I also think kind of maybe an underlooked or kind of underestimated aspect of this is the subjectivity, right? And that kind of comes from the non-determinism. A lot of these problems, it's almost kind of like a UI, a UX kind of design. You kind of have to look at it and say, like, does it seem right? Is it answering the questions the way that I want? In addition to the sort of correctness problem, and I think that's largely where a lot of my focus has been on. How do we evaluate these chains that these applications that people have built?
Got it. Well, I actually think that UX UI analogy is really interesting because we think about, I mean, from a pure software perspective, have built many tools around ensuring that a button is on a page sort of thing, but they don't tell us if that button is in a good spot? Is it alluring to the user? Whatever. Like, is it optimized for the flow of the user? And so as a result, we get, it's always a human sort of driven feedback model, right? Whether it's before, like watching people doing research, doing sort of like trial runs, et cetera, or after putting things in production and seeing how people respond to it. And so does that carry over then into how you're thinking about testing for some of these, non-deterministic parts of applications?
Yeah, I think it definitely becomes a thing that you now have to evaluate for, right? So, we can maybe get into the nitty gritty of how some of this works, but the general, the term that folks have adopted for this is this idea of evals, right? It kind of comes from more of the research side of things. This idea of you've built a model, you need to evaluate it against a standard set of benchmarks. But in practice, when you're building an AI application, you really have to test for your use cases, right? It doesn't really do you any good if a model does really well on like a kind of industry standard benchmark that's good for comparing models against each other, if you're sort of producing the wrong outputs for your customers. And so, so when you think about evaluating these systems, there's definitely the correctness aspect. There's non-toxicity, but there's also a sort of like, you might think of it around like helpful, right? If you're writing a bot to sort of answer questions, you might want the AI to be a little more friendly, and not just sort of like, here's the facts, right? Depending on the tone you want to strike. So yeah, there are definitely these sort of subjective evaluation criteria that you want to evaluate, and unfortunately, they're subjective, right? So you kind of have to spend some time tweaking and playing around with it. And you're starting to see some of that in how a lot of the tooling around building these applications is evolving to make it easier for people to play around with these kind of subjective criteria.
So yeah, that makes a ton of sense. And I think there's like, you said we can get into the depths of it a little bit. I mean, the thing that really seems interesting to me, and all I can think is turtles all the way down, is this notion of LLMs testing LLMs. And so I think when that was first introduced, there was a lot of, well, the LLM will just say, I am right. But the reality is LLMs don't care yet. Right? They don't have personalities and opinions. They just have whatever they generated. And so can you talk a little bit more about how that works and like why it makes sense to use that kind of tooling?
Yeah, absolutely. I'll throw in like a term for people to Google if they're interested. So model graded evals is sort of the catch-all term for this. You can find some good resources on this. And so the basic idea is, okay, we've trained this large language model on a ton of text, on a ton of human produced output. We are now asking a language model to produce, human sounding output. So, how do we make sure that it's right without resorting to just string matching kind of thing, which doesn't really work because of the probabilistic nature of it. And so the approach is like, well, we've got a thing that kind of understands text. Can we ask it questions about its own output, and then have it grade it, right? So this is, again, model graded. If you actually look at some of the terminology, if you look at the prompts that people use, they kind of use the analogy of a student and a teacher. That's how a lot of these prompts are structured. And so, yeah, I mean, the theory basically is that, hey, if it's able to tell you an answer to a question, it's also been trained on like, oh, that's not a great answer, let me reword this. Can we also ask it questions around how to evaluate it, or how well the output performed? Now, I will say there's a certain level of caution here, right? I think the folks from Hugging Face have done some really good research. Certain models prefer their own output, right? I think GPT-4 actually has a slight bias to prefer output from GPT-4 over other models, which is kind of not super surprising, right? Its notion of correct, and I put notion in air quotes because there's not really a world understanding of these models. It's probability distribution, if you want to be precise. So yeah, that's kind of the idea is have something that kind of knows, again in air quotes, what good looks like, and just ask it. Kind of like how you might ask a human to eyeball a web page, see, okay, does this seem right? Use the model.
Right. Yeah. I mean, the thing that's interesting in there is, yes, have a human look at it, but in this case, at least getting to a place where obviously we think a lot about CI and CD pipelines, like as I'm iterating and delivering, I have a tool that can say, this is good enough, maybe not this one. So on the point of biasing towards your own, I struggle to not give personality to these machines. Biasing to your own output, are there sort of common practices or real value that we're seeing in using a different LLM to validate? Like then you kind of get two views of the same sort of correctness. Does that make sense?
Yeah, and I'll even say it's sometimes the bias isn't even model specific. Sometimes it's like position specific. So I
Mm,
forget the exact stats, but it's like if you ask it, compare left and right, kind of if you think about it, like
mm,
there's a bias towards the left to always say like the left is correct. So
mhm.
that creates this. I mean, again, you kind of have to think about your risk tolerance for those sorts of things. But a
Yeah.
lot of the ways that you would approach it would be, and it's actually interesting that some of the maybe less used software techniques, but like table driven testing, right? So it is like give it multiple scenarios, right? Weight them, run through multiple examples. Randomize is obviously one way to approach this. And so it's really about sort of building up confidence, right? So,
Hmm.
you don't want to test on a single example. You might want to test on multiple examples, tweak the wording a little bit. There's kind of, I'm going to keep drawing analogies to traditional software, but you think of like mutation testing, go in, randomly change the code, and see how it fails. You can do that with these LLMs. Take the output and use like maybe a cheap model or GPT-4 if you got the cash, and have it reword the question, then ask it again to evaluate, and sort of tweak the inputs a little bit, just to give you some more confidence. Right, if you're repeatedly getting the same answers, you can respond with a you can proceed with deploying with a pretty high degree of confidence. But at the end of the day, right, it's not a human actually evaluating it. It's not, your test cases are not production, right? And so I think some of that human review is still very, very important.
Yeah. Yeah. Well, I mean, I think that there's going to be some nervousness. I can't think of a better word right now. Around all of this for a little bit. I think one of my key takeaways from that description is, as you talk about bias, none of the tools are going to be perfect. So you need to understand the behavior of the tool and build your system in a way that's going to allow you to, offset that behavior, I guess is the best way that I can describe it. No, like there's nothing perfect. There's no single, like, as long as you do it this way, everything's going to be great. So understand your context, understand your tools, and then know how to apply them. Because we'll just throw it out there and hope that our customers love it is not necessarily going to be a fantastic strategy. Like you definitely
For
want to find a
anything.
way to, yeah, true,
Yeah.
absolutely. That's
For
one thing
any,
that we've
yeah.
learned many years now. And so sort of taking that knowledge from research around evals and how do you apply the stuff and then bringing it into sort of, applied software delivery, if we will, feels like at least there's hope. We see signs, we see approaches. We're still learning from them or learning how to use them and improving them. The other thing that you mentioned in there, sort of off the cuff on GPT-4, was if you have the cache, you could do this. So, this is an interesting concept where the foundation models are so powerful that many of us don't even have to train or build anything to get to a point where we have like an interesting product, right? At least a product idea, put it out there, see if people are responding to it, then maybe we'll tailor it. But at the rate that we have all subscribed, I guess, to like testing, test-driven development through to CI/CD pipelines for every change, deploy like multiple times per day, I can imagine that the very large set of test cases you're describing starts to, ring the cash register, if you will. How are you thinking about strategies around approaching that?
Yeah, I mean, it's a great question. And I mean, cost is definitely a factor, right? But human time is also really expensive. So
Mm-hmm.
like using the more powerful models, I think is a really good strategy. But yeah, I mean, I think to your point, yes, if you attempt to retest every case possible, right? Like then that will become prohibitively, not even like cost expensive, but like time expensive, right? I mean, these LLM models are they're not high throughput query systems, right? They're
Mm-hmm.
not, they're like, yes, there's a lot of infrastructure so that in aggregate they can support, however many tens of millions of people are using them. But they're not kind of like tuned like a database would be for high throughput operations. And so like time becomes expensive, right? You would, I would imagine, or not imagine, the way I think about this, it's kind of like testing with production, right? The goal of testing is not to test exhaustively. If you wanted to test exhaustively, you would log every single request your application had ever gotten, the output of it, and you would replay it every single time. And that might give you a ton of confidence, but it would be very time consuming. I think you would use similar strategies with AI. What are the important flows, right? What are the most critical sort of user journeys that you care about? What are failure modes that you're particularly concerned about? If you've got an application that's like free form chat, you probably have to you need to be concerned about people adversarially prompting, right? People asking you to people love to go into these LLMs and ask them to say terrible things, right? So you probably want to consider that sort of sanitization and moderation for your application. If you're largely focused on internally classifying survey response feedback, for example, you're probably you maybe aren't as worried about these use cases. So I think you still have to think through what are the core user journeys, what are the things you want to test, what are the absolute minimums of your application, and then what are the things that hey, if something goes wrong, right? If an LLM gives kind of like a mediocre answer, or it can't really solve the problem, it's too complicated. Making sure you have code to handle fallbacks and errors when they produce. So this example comes up if you're using function calling, which is a feature OpenAI kind of launched first, which is like you can tell it, hey, I have this function that accepts a JSON payload. And you kind of tell the LLM to call your function, but what you're really using it for is serialization. You're using it to take the response and structure it. We found this with the self-healing pipeline work. Those function calls are not always 100% accurate, right? Sometimes it doesn't give back valid JSON. And so then it becomes like an error handling strategy, which again kind of falls back into a normal software development flow. What do you do? Do you retry? Do you just say like, okay, we'll go down a fallback path? So I would say, yeah, like understanding the critical user journeys, identifying data sets that are sort of critical, like table stakes for the LLM to answer that you always want to evaluate, and then probably mixing in error handling, and then maybe the last bit would be building a kind of the idea of a data flywheel, where as people are using this application, putting in a mechanism to provide feedback could be as simple as thumbs up, thumbs down, could be behavioral if they reprompt, if they regenerate a response, tracking that, and then using that to feed back into your testing systems. You can sort of build up confidence over time.
Yeah, I think that's a very interesting space to think about. Like, unsurprisingly, I'm applying a lot of what we think about, we'll call it classic software delivery, all of the tools that we've built over the years to mitigate risk and how they can be applied in the space. And, we collect signal as we're deploying, for example, or releasing software around how our users are behaving, but it's mostly, response times, are we getting errors, are people clicking or not clicking? But everything the user does is some sort of feedback about how the model is performing, or how your product built on top of the model is performing, and being able to really analyze that. Like, do people take the next step, or do they walk away? Do they reprompt, to your point, with the, and what is the structure of that reprompt? Is it, could you change this slightly, or is it, what are you even talking about? Is there a human that I can talk to? Like, I think it's that whole scale, and the signal is in there, and figuring out how to parse out that signal will be a fascinating journey. And to really hammer your point home, focus that energy, because it's a hard problem, on the things that are going to be of greatest value to your users, right? Like, where are you truly differentiated? How is this capability going to truly differentiate you? And can you invest the energy there? Which is not to say, I guess, the first feature you should build if you're thinking about building AI features is something absolutely critical to every person's flow, because maybe you should, apply the sunscreen in a spot that no one can see, just to make sure it doesn't, whatever.
Yeah. And that's just carried through to your testing strategy too, right? Like, there are absolutely things that are invariants that you'll spend the money for a really expensive eval for those things, and for other things you might use, distance metrics or some other kind of cheaper, quick way to check. Yeah, but yeah, absolutely, 100%. You need that user feedback. It's very valuable signal.
So we've talked a lot about how easy it is to get started, and then some of the things to consider around just making sure it's working, it's providing value to customers. I think one other thing that people are thinking about, because we love to think about this as engineers, I don't know how many of us are there yet, is then how does this scale? And sort of okay, it's actually not accurate enough or it's too expensive? Like, what sorts of tools do we have at our disposal right now to figure out how to scale a platform?
Yeah, so I mean, I might break down scale in a couple of ways, right? So I mean, there is literally like, can you handle the traffic load, right?
Mm-hmm.
And so that might be those decisions might be, do I so like let's assume you're going to use a foundational model. It becomes like not so much am I going to train the model, but will I pay Azure has an OpenAI deployment. You can buy your own GPT for hosted thing like
Mm-hmm.
those sorts of things. Do you purchase your own or do you kind of stay in the pool with OpenAI. And you can do that you can get some dedicated capacity for certain foundation models from other providers. So that's one aspect of scale. Kind of, again, that's kind of a classic throughput level. I think what you're maybe getting at is sort of what it really comes down to at a certain point is kind of cost, right? I think
Mm-hmm.
that's more your question. I mean, so yeah, I mean the the token fee based model providers. So there's kind of two broad ways that people get charged, right? Usually hosted model providers charge you per token. It's not really per word due to details of how the models are changed per token. So they charge you on a per token rate, and you can usually go through and look at reports and cost. OpenAI recently their cost reporting, they started breaking things down by what's GPT-3 5 versus GPT-4, because now they have these like fine tuning models, which maybe we'll talk about in a little bit. So I mean, honestly, it's just kind of like look at the bill, like look at the invoice, like see where the costs are going, and then sort of compare that with what's the value that you're getting. And so, yeah, you kind of need that link to what are your product metrics that you're trying to drive.
Mm-hmm.
And so, yeah, when you talk about cost, right, the cost management, some of it is like, do you fine tune an OpenAI model to make the prompts shorter, right? So you pay for tokens in and you pay for tokens out, is typically the pricing model there. So yeah, do you consider fine tuning? Do you sort of maybe push certain things to cheaper models? So this idea of like routing is, if it's a hard
Mm-hmm.
query, use the expensive model. If it's a simple query, use a cheaper model. The trick there, of course, like with any type of scaling strategy, right, is the more knobs and paths you create through the system, the more you kind of have to manage and make sure it's working properly.
Yeah, that makes sense, and I think this problem I sort of led with this. Like, I don't know how many of us are there. I think there was some recent reporting about OpenAI themselves and sort of what it's costing them to to operate versus what they're generating, those sorts of things. But like, probably everything's going to get cheaper because it always does, right? And there are tools out there that everyone is exploring, and that space is going to evolve quickly. I think we're going to say, oh, okay, under these conditions, to your point, like routing, under these conditions, this actually will give you a totally good enough or maybe an even better response for 50% of the price. But these are things you should be aware of as you're thinking about building these kinds of applications. I don't need to solve this today, but if I succeed, I'm signing up for this kind of work down the road. And so I should understand how that's going to play into my app. Like, if I reach a point where I can't serve my users with this and I have to turn it all off, was it worth the investment? Unknown, right? But know that that's kind of a thing that's coming up down the road, is what I would think about it.
Absolutely, and I not to keep leaning into these are a lot of the same problems. This is true of any managed service, right?
Mm-hmm.
Any managed service
Mm-hmm.
becomes very easy to get up and running very quickly. Low operational overhead. You don't need to find an expert, which in the AI world, there's maybe 200, 300 people who can like really give you your own AI system. Kind of going to be hard to find those folks. So like, yeah, leaning into the expertise that folks have. I mean, it's usually a pretty solid strategy for software, as long as you're aware that at a certain point there's going to be a bill, there's got to be a number where it's like, okay, like at this point we need to start thinking around, cost management and alternatives. Yeah.
It makes me, when you said it's true of everything, like I think about all of the businesses that have been formed around cloud cost optimization. And I feel like we just predicted a whole category of like foundation model cost optimization. Like, that's probably a bit, if you're listening to this podcast and you like just quit your job and you're not sure what to do with yourself, this is a business, I promise you. I don't know who's going to win in that space, but it's definitely going to be a business, because it's going to get real fast. People are super excited about this technology. They're scrambling to build stuff with it. And, and then the bill's going to come due and they're going to say, okay, this is amazing. We want to keep it. How do we just optimize it and get the right ROI? Awesome. Well, very cool takeaway. Thank you so much for sharing details on all of this. Very well explained as always. And I guess, I didn't know it coming into this, but anyone listening who doesn't know what to do with themselves right now, we just gave you a business to go build. So that should be exciting. I think this whole space is super exciting. So thanks everyone for listening today. If there's anyone you want to hear us interview, topic you want us to talk about, find us on Twitter at CircleCI. And of course, if you enjoyed the podcast, subscribe on your podcast provider of choice and share it with all your friends. Webster, thanks again for joining me. This was awesome.
Yeah, absolutely. Thanks for having me. Anytime.